All right, the next section, 7.2, using the converse of the Pythagorean theorem. Now remember, the Pythagorean theorem only works with right triangles. So the converse of this is, if the square of the length of the longest side of a triangle is equal to the sum of the squares of the lengths of the other two sides, then the triangle is a right triangle. So in the Pythagorean theorem, you know the triangle is a right triangle, so then the Pythagorean theorem works. The c squared equals a squared plus b squared. And the converse is, if we can show that a squared plus b squared equals c squared, then we can show that the triangle is a right triangle. So it's when you don't know that the triangle is right or has a right angle, you can set it up like using the Pythagorean theorem, and if it comes out to work that a squared plus b squared does equal c squared, then you know it's a right triangle. So we are verifying right triangles. So tell whether the given triangle is a right triangle. So first, looking at 6, 9, and 3 square root of 13, I need to identify the longest side. The longest side is going to be represented by C. Now, just looking at the triangle, it looks like 3 square root of 13 should be my hypotenuse because it looks like 6 and 9 are forming a right angle. But just in case looks are deceiving and they're in the wrong place, they're just numbers out there, you do need to punch in 3 square root of 13 and see what you get. It comes out to 10.8, which is longer than 9, so that is what we're going to use for our hypotenuse, or our C value. So 6 can be our A, 9 can be our B, and 3 square root of 13 can be our C. So 6 squared plus 9 squared, and we're going to set it up equal to 3 square root of 13 squared. So 6 squared is 36, plus 9 squared, which is 81, and then 3 square root of 13 squared is 117. And if you punch this into your calculator, 3 square root of 13 squared, you need to have 3 square root of 13 in parentheses. And then have the squared sign outside the parentheses. So just like I have it written there is how you need to punch it into a calculator. Okay, so 36 plus 81 is also 117. So 117 equals 117. So it came out the same on both sides. Yes, it is a right triangle. So let's look at B. We have lengths of 16, 24, and 29. 29 being the longest, so that's going to be our C. And our other two can be our A and B. It doesn't matter which one. 24 could be the A, 16 could be the B. Doesn't matter. So we've got 16 squared plus 24 squared equals 29 squared. And really at this point we don't know if that actually equals. We didn't know that it equaled each other until we got down to 117 equals 117. So 16 squared is 256. 24 squared is 576. And 29 squared is 841. So let's add 256 and 576 and see if we get 841. We would get 832. So 832 does not equal 841. So I put that line through the equal sign showing it does not equal. So it is not a right triangle. Or no, not a right triangle. So our two sides have to come out equal for them to be right triangles. Just give me the same questions again. There we go. All right, so methods for classifying a triangle by angles using its side lengths. So there's more information we can get using this Pythagorean theorem setup than just determining if it's a right triangle or not. We can also tell if they're acute or obtuse triangles using this method. Now, remember, if they come out equal, they're going to be right. But if they don't come out equal, that's going to tell us whether it's acute or obtuse, and we'll talk about which way is which. So here we have theorem 7.2. If c squared equals a squared plus b squared, then the measure of angle C equals 90 degrees, and ABC is a right triangle. But theorem 7.3 is, if c squared is less than a squared plus b squared, then the measure of angle C is less than 90 degrees, and then triangle ABC has to be an acute triangle. And so 7.4, if c squared is greater than a squared plus b squared, then the measure of angle C is greater than 90 degrees, and triangle ABC is an obtuse triangle. So classifying each triangle as acute, right, or obtuse, just by these side lengths. So these three numbers up here are my three side lengths of a triangle. So even though we don't have a triangle drawn, they're telling us that these are the three side lengths. Tell if the triangle is acute, right, or obtuse. So I need to identify my longest side, my biggest number, and my biggest number is going to be my C value. So that would be 37.5, so that would be my C. 10.5 can be my A. 36 can be my B. So I would have 10.5 squared plus 36 squared equals 37.5 squared. So 10.5 squared gives us 110.25. Do not round these decimals. You must leave decimals as they are. Plus 36 squared is 1,296. We need to see if that will add up to be equal to 37.5 squared. That is 1,406.25. So again, we're not rounding the decimals. So 110.25 plus 1,296 equals 1,406.25. So they do equal each other. So they are a right triangle. All Our next example, number 2, we have 12.3, 15.2, and 23.5. So my longest side here is 23.5, that'll be C. My other two can be A and B. So I have 12.3 squared plus 15.2 squared equals 23.5 squared. 12.3 squared is 151. Sorry, 151.29. 151.29. And then 15.2 squared is 231.04. We need to see if that equals 23.5 squared. 23.5 squared is 552.25. Add our first two numbers together. We get 382.33. Drop down 555.25. Now I haven't put in the equal sign because now we want to look at is, obviously they're not equal. Which number is greater than the other? 555 or 552.25 is greater than 382.33, or 382.33 is less than 552.25. Well, our 552.25 was goes with our C value, is our C squared. So that means that this is going to be obtuse. Remember, if the angle C is greater than 90 degrees, it's an obtuse triangle. And to know that it's greater than 90 degrees, if we find out that C squared is greater than A squared plus B squared, it's obtuse. So we have an obtuse triangle. Next, we have 23, 25.2, and 18. 25.2 is our longest side. And we have 23 and 18. So I have 23 squared plus 18 squared. And we don't know if it's equal, but I'm going to set it up as if it is 25.2 squared. So 23 squared is 529. 18 squared is 324. And then 25.2 squared is 635.04. I need to add my other two together, which gives me 853. Clearly that is greater than 635.04. And 635.04 was my C squared. So my C squared is less than A squared plus B squared. So this one is an acute triangle. Then my last example, we have 8, 27, and 21. 27 is our longest, so it gets the C. 8 can have A, 21 can have B. So 8 squared plus 21 squared. Let's just not get in the habit of putting the equal sign there. Just add in a question mark that we're not sure yet. 27 squared. 8 squared is 64. 21 squared is 441, question mark, and then 27 squared is 729. 64 plus 441 is 504. And bring down the 729. 729 is greater than 504, or 504 is less than 729. 729 was our c squared value. It is greater, so our triangle is obtuse. Obtuse triangle. All right, that is it for 7.1 and 7.2. Make sure you do the 7.1, 7.2 homework.